the while loop. And again, let's check what is in A. A should have no elements. As you can see, it's an empty list. When I checked what's in A, it's an empty list. And that is why while A returned me a false and we did not print any further. So this is an example of using a while statement using lists. And of course, the next topic would be discussing nested while loops. And this is a broad topic. What I mean by this is that when I'm saying nested while loops, I'm actually talking about nested control structures. So we can have while loops within while loops. Not only that, we can have if and else statements within while loops. We can have while loops within if and else statements. And we can have if and else statements within if and else statements. So if you think of all of these loops, and we will even speak about for loops in another video. For loops again are a type of control structure. So all of these are control structures. While loops are control structures. For loops are control structures. If and else statements are control structures. All of these are control structures, and nesting can happen within them. And it does not matter which is the parent of the nest and then the child of the nest. You can have a while loop within an if and else statement. You can have for loops within a while loop. All of this is valid in Python, and it's one of the great features of Python that is very flexible in this way. So let's look at an example where I have a while loop within another while loop. So I'm copying this piece of code where I have this list 1, 2, 3, 4, 5 and another list first and second. Now my first while loop, I print what is popped from A. So I take A, then I pop the 0th index. So basically from the left hand side, and I print what is that. Alright. And then I have another while loop where I have this list B and I'm doing the same thing. But this while loop is within the first while loop, and let's see what happens out here. So as you can see, my first iteration of this parent while loop causes me to pop what is the first element, which is 1. Then I do these while loops and this is completely executed, and only then do I go back to this first one. And then I come back and do all of this again. Then I go back to this one and then I come back and do all of this again. And that's why you can see this repetition. So I have this first iteration and then I do the second while loop. Then I have the second iteration and then I do the second while loop, and I keep doing this. And this is an example of a nested while loop. Okay, so our next topic in this video would be break and continue statements. Now break and continue statements are ways to abruptly end iterations in a particular loop. You can use break and continue statements not only in while loops, but you can use it also in for loops. So let's look at how we use it in while loops. And let's look at what we mean by break and continue statements first of all. Well, the break statement terminates the loop entirely. So once the break statement is found, the complete while loop that we are using is completely terminated. And the continue statement, on the other hand, terminates only the current loop iteration, and it goes back to the beginning or the expression, and it checks whether the expression or the controlling expression is again reevaluated, and it is checked whether the loop will execute again or terminate. This pictorial that you can see here actually emphasizes, or it shows the difference between break and continue. So I have this while loop and I have an expression. Alright, I have a bunch of statements and I have a break command over here and I have a continue command over here. So if I encounter the break command, it will not execute any of this. In fact, it will not execute this while statement at all, and it will move on to the next piece of code that we have. But a continue statement, if a continuous statement is encountered in a while loop, will not completely break away, but it will not execute the rest of the statements in that iteration, only these two, but it will go back here, it will check this expression again, and again we will do this all over again. So this is this small difference between the break and continue statements, but both are used to abruptly end an iteration in a loop. So let's look at an example of how we use the break statement. So I will use this example where I have initialized some controlling variable n to 0. My first loop will check whether n is less than or equal to 5. If this is true, then I will print this statement. Then what I'm doing over here is I am incrementing it by 1. Now in my earlier example using the similar example, I had no, this part was not there. So what you got was, I was printing the value of n. So it was printing as value of n is 0 and then 1 and then 2 and then 3, 4 and 5. But over here I've included I've nested an if statement, and within that I put a break statement. And this if statement is checking if n is equal to 2. So once n is 2, I move on to this and I do the break statement. So let's see what happens now. as you can see, so when I have executed this, I don't get the whole value of n is 0 and then 1 and then 2, 3, 4, 5. I stop at 1, and that is because once n is equal to 2, I actually do not execute this while loop again. I do not go back and execute print value of n is 2 now. In fact, I break from this whole while loop, and my while loop terminates right then and there. And that's why you only get these two iterations, value of n is 0 and then value of n is 1. Okay, so now I'm going to show you a neat example of what happens, or what is the difference between a break and a continue statement. Okay, so let's go back to our initial example where we're printing this value of n is 0, 1, 2, 3, 4 and so on. But I've added one more statement where I print hello at each iteration. So let's see what happens when I do this. As you can see, it will print hello after each of whatever I was doing already. Now let's introduce our break statement first of all. So when I do break, well, let's go back to this if statement. If we check this condition, then we break. Let's see what happens now. As you can see, something interesting has happened where we have this first iteration completely being executed, but the second iteration kind of stops where there's no hello, and that is because we have broken from this while loop before the second iteration's hello was printed. Let's see the difference between a break and continue now. So now I have this continue statement instead of a break. Let's see what happens here. As you can see, it seems familiar to our first example where we did not have any break or continue. But there is a small difference that I want you to catch, and that is very important about this continue statement. So as you can see, the first iteration has value of n is 0 and then hello. Then value of n is 1, but there is no hello. And this is because once this condition is actually met, we do not move on to this statement, but we go back to this expression and we evaluate this expression. And then once we evaluate this expression again and it's found to be correct, we do everything the same again where we print hello. But except for that one step where this if statement was met and we did continue, and this following statement was not executed. And that happens only for one iteration, and that is when n is equal to 2. And as you can see, that is what happens over here. In one of the iterations, we miss a hello, and that is the difference of the continue statement between, that is the difference of the continue statement with the break statement. This video will be an extension to that topic where we will be looking at 3 examples where we are using while loops along with other stuff like say if and else statements. So our first example will be where we calculate the factorial of a number. In this example, as you can see here, we are first going to ask the user to enter a particular number for us. Now this number is supposed to be an integer. Once we have this integer, we store it to a variable called number. Now we have this, you can say this variable called FAC which stores 1, and we will see how we are using it later. Now we know that the factorial of 0 is 1. That's how it's just defined. So we have an if statement checking whether our entered number is 0. And if it is 0, we say that the result is 1 or the factorial is 1. However, if we enter a number that is greater than 0, we must calculate the factorial for this number. And that is what we are going to do in this else statement block over here. Now in this else statement block, we have a while loop. In this while loop, the condition is checking while number is greater than or equal to 1. So as long as this condition is true, everything within that while loop will be executed. So as long as number is greater than or equal to 1, we are going to execute these 2 lines. Now what do these 2 lines do? Let us see. So the first line takes the variable FAC where we had the number 1 stored, and we are going to store FAC times number into it, number being the number that we have inputted. So in case, for example, we entered 8, then what this line will do is 1 into 8, and it will store that back into FAC. Now once that is done, we move on to the next line where we are decrementing the number variable by 1. So if we have stored 8 or we have entered 8 into our input, it will become 7. Now as we know, 7 is still greater than or equal to 1, so this condition is still being met. And then we do this process again where we are going to multiply FAC. This time FAC stores the value 8, and we multiply it times the new number, which is 7 now. So we do 8 into 7. And then again we decrement this. Also once we do 8 into 7, we store it back into FAC. And we keep doing this where we keep multiplying 8 times 7, and then we decrement the number variable by 1. And then we check this condition again. So what ends up happening is we are going to keep doing 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. And once we are at 1, again when we do this decrement operation, the number variable will store the value 0, and then this condition will no longer be met. So number will be 0 and this condition will be false, and we can move out of this while loop. And then finally we store the result into a variable called result, which stores the result of 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. This is of course if we did enter 8 when we were asked to give an input. So let's see this in real time once we execute this. So I'm executing this. The first thing it asks me is to enter a number. So let's say I enter my number 8, as I was speaking about 8. Alright, now that I have entered 8, as you can see, the result that it gives me is factorial of 8 is 40320, which is correct, and you can check this for yourself, where it will show you 8 times 7, or 8 factorial is basically this number. Okay, so now in our next example, we will be looking at how we can generate Fibonacci numbers. For this example, we will be using bunch of if and else if statements along with a while loop. So let's look at this piece of code where we are actually doing this. So as you can see, the first part of the code is basically an input statement asking us how many Fibonacci numbers we would like to generate. And then the user would be asked to give an input, which is stored as an int into a variable count. Now in this if-else statement, the first if statement checks whether what we have entered is 0, in which case we just store an empty array in the variable called fib. Next, if our entered integer is 1, we just store the value 1 in this array called fib. If our entered number is 2, we store 1 and 1 in the array fib. All of these are different sets of Fibonacci sequences. This obviously an empty array shows that, well, there is no numbers to be generated in this sequence. If we have 1, we just print the first number of the Fibonacci sequence, which is 1 itself. If it is 2, we print the first two numbers, which is 1 and 1. Now, the actual calculations happen when we say we want a Fibonacci sequence for more than 2 numbers. Now, in that case, we move on to this block. In this statement block, we initialize the fib variable with the first two Fibonacci numbers 1 and 1, and we store in this array. Now, we are going to do a while loop within this, and in this while loop, we're going to keep executing this statement block as long as this condition is met, or this condition is true. And what this condition is it's checking this variable I, which we have initialized as 1 over here, and we're going to check whether that is lesser than count minus 1, count being the number that we have been asked to input. If the statement is true, and as long as the statement is true, we will be executing this statement block, which is basically us appending this expression into the array fib. Now what this expression is basically, it's going to keep adding each subsequent numbers, and we're going to store each subsequent numbers back into the array fib. So in this case, if you see, what the first step will do is it will take the value at the first position of the array fib, and it will add it to the value at the 0th position of the array fib. And both of these values, since they are 1 and 1, when we add them, we get 2, and we append that to fib. So now our fib will look like 1, 1, 2. Then we increment this by 1, and what we do is we do the same process again. So in the next step, what we would do is we would do 2 plus 1. So we would get 3. Now this would keep going on until this condition is met, or basically until the numbers that we actually want to generate in our sequence. So let's execute this, and let's see an example of what happens. So it asks me how many Fibonacci numbers I would like to generate, and I will say I want the first, let's say 6 Fibonacci numbers. So I execute this. As you can see, this gives me the first 6 numbers in the sequence, which is 1 and 1, and then 2, which is basically 1 plus 1, and then 3, which is 1 plus 2, and then 5, which is 2 plus 3, 8, which is 3 plus 5. So if we wanted more numbers, we would just enter over here. Like say if we wanted the first 10 numbers, it would give us the first 10 numbers in the sequence, as you can see here. Now in our next example, what we are going to do is we're going to write a program which takes 2 digits that represent the dimensions of an array. For example, if we want a 3 by 3 array, we will enter 3, 3, and we are going to generate a 2-dimensional array in which each of the elements of the array are basically the row times the column position of that particular element. And what I mean by this is, say we have a position I comma j on the array. The value of the element at that position would be I times j. So for example, if I'm looking at something at the third row and the fifth column, or say the third row and the third column, for example, the value of the element would be 3 times 3. And if I'm looking at something at the second row and the fourth column, I am going to do 2 times 4. So let's see how we can do this using code. So if you look to the right over here, I have a piece of code where I'm going to where it asks me to input two numbers, two integers, to represent the dimensions of my my sample array. Now once we have done this, we are going to store these dimensions in the inputs in a variable called input string. So obviously when we enter say 5 comma 5, that will be stored as an int in this particular string or this variable. What we want is, we want 5, say we entered 5 comma 5, we want 5 as a separate integer and the other 5 as another separate integer. And that is what we do in this particular statement, where we're going to split up our input string based on the comma separator, and we're going to store the first part of that string into the 0th position of dimensions, which is an array, and the next dimension in the first position in this particular array. Now we're going to store the number of rows as row number, and that is the 0th position of this array, and we're going to store the number of columns as the first position of dimensions, or whatever we've mentioned in the input. So now we have this our results array called multi-list, which is basically what our final array is going to look like, and we're going to store into multi-list. And in this example, we will be using for loops to do this, or to create this particular array. So as you can see here, our first we have initialized our multi-list, saying that we're going to have only zeros in our sample array. So initially, once we have initialized this array, all multi-list will contain is a, say for example, we have inputted a 5 by 5 array. It will have basically a 5 by 5 array with all elements as 0. And that's what this line does. Once we have done this, we are going to move on to the for loop portion, where we are actually going to create our array that we want. So as you can see, our first for loop is going to say for row in range row number. So obviously range will generate an iterator which can be iterated over, and since it says range row number and say the number of rows that we entered were 5, what it's going to do is it's going to create an iterator containing the value 0, 1, 2, 3 and 4. So for row and range, it will basically row will take the value 0, 1, 2, 3 and 4. And a similar thing is going to happen in this nested for loop, which is within this, where we're going to again create an iterator using this range function and for the column number. Once we have this, we're going to do the simple process of multiplying the value of the element based on its position. So if it's at the position 3 comma 4, we're going to store the value 3 times 4 into that particular position of the array. And we're going to do this for every position, which is what happens in these two for loops. We're going to first go by each row, and then within that we're going to check each column, and we're going to perform these calculations. And finally we print our result. So let's look at an example. Now I'm going to say I want a 3 by, let's say a 2 by 4 matrix. So let's see what the results will be when I give this as so what I'm saying is I want 2 rows and 4 columns. Now as you can see here, it might not be very clear to you right now, but what you can see here is this is the first row and this is the second row, and each row contains 4 columns. So these are this is my final array that I get. So what you can see here is this is the 0th position, and the or you can say this is the first row, first column, first row, second column. And since Python is 0 based, so this is actually the 0th row and this is the first row. So as you can see, this value basically is 0 times 1. This value is 0 times 2, 0 times 3, 0 times 4. And over here it is 1 times 0, 1 times 1, 1 times 2, 1 times 3. So similarly, if I did, for example, a 5 by 5 matrix, what you will get is 5 rows now, 5 rows and 5 columns. And for example, like this particular value is 1, 2, 3, or 0, 1, 2, 3. So 0, 1, 2, 3 and the first column. So this is 3 times 1. If I took this value, this is like the fourth row, for example. Fourth row times the 0, 1, 2, 3 third column. So this would be 4 times 3, which is 12. So, and each value of this has been generated in the similar process. So this is an example of how we can use for loops for a particular exercise that I have shown you right now. In this video, we will be covering the topic of definite iterations using for loops in Python. So starting off, we know that there are two types of iterations in programming, definite and indefinite. We have already covered indefinite iterations in the form of while loops. Definite iterations, on the other hand, are done using the keyword for, and the basic syntax or the standard syntax for a basic for loop in Python is as you can see over here. We have this for keyword, we have some variable, we have the in keyword, and we have this iterable, and we of course define this control structure with the colon, and then indented we have this statement block. So once this for loop has started, we execute all of these statements within the statement block as part of the for loop iteration. So yeah, let's to understand like how for loops work exactly, let's look at the concept or meaning behind what we call iterables and iterators. So think of it in a stepwise manner. Alright, so in Python, we have different objects that can be used as iterables, and an iterable is basically some object that it's a collection of other objects. So, you know, think of your lists, think of dictionaries and sets. So all of these are essentially collections of objects. So once we have these collection of objects, we can create an iterator out of it. How do we do that? Is we use the iter function. So for example, if I passed this list A through the iter function and I store it in some variable iter underscore A, and I see what is iter underscore A, it is actually a list iterator at some random memory location, which we don't really care about. Similarly, if I gave a tuple and I did the same thing, I will create a tuple iterator. And in the left, if you can see over here, I've done the exact same functions with sets and dictionaries as well. So I'm creating iterators out of these iterables, so as to speak. Now what is an iterator? Well, an iterator is an object that yields values successively. So if my list contained 5 values or 5 objects, an iterator of this list will yield these values one after the other. And that is kind of how, or that is the basis for which we create loops. Let's see what we exactly mean using this, using another function that we call the next function. So the next function keeps moving from object to object within an iterator. So since I've created this list iterator, let's just do it once again. So as you can see, I've created this list iterator iter underscore A. Now with this iter underscore A, what I'm going to do is I'm going to use this next function. What next function does is, starting from the leftmost object within this iterator, I will keep yielding, or I keep producing the values. So let's just see what happens when I do next when I do next for this particular variable. It gives me this object first. Now let's see what happens when I do it again. Now it gives me the object second. What if I did it again? It gives me third. Now if I kept doing this, it will keep giving me the different objects that were initially stored in A. That is first, and then second, third, fourth, and fifth, one after the other. So let's actually perform that. Now I get fourth. Now I get fifth. Now a natural question is, now that I've exhausted all of these values, what will happen if I perform the next function again? Well, let's see what happens. I get an error, and this error is the stop iteration function error, which basically is telling me, look, you have exhausted all of the objects that were initially present in this list A, and you cannot keep doing the next function anymore. You cannot keep going further. So yeah, so this is what the next function does when it comes to the concept of iterators. Alright, so now we've learned two things. What is an iterator, and how do we create an iterator out of different collections of objects like a list or a tuple. And we've also learned how to use the next function. Now let's let's come back to our for loop that we started off this video with. So our for loop again, let's consider our for loop over here. As you can see, some for loop with the objects again 1, 2, 3, 4, and 5. Alright, this is a list. Now I'm going to do for x in A, print x. And let's try to see what happens when we do this. Okay, as you can see, when I have executed this, it gives me 1, 2, 3, 4, and 5. So first of all, let's look at this for loop. In this for loop, I define a new variable x, and then I say for x in A, print x. And what's happening? Well, in each iteration, I'm printing whatever the value of x is at present. So in the first iteration, it is the first object 1. In the second iteration, it is the second object 2, then 3, 4, 5. And then finally, on its own, like this for loop knows that, okay, now once I have exhausted all of the objects within my iterator, I can stop doing this for loop and I can move on with the rest of the code. Alright. So think of it like a 3-step process, a for loop in Python. The first step is it calls an iter function to obtain an iterator for whatever we pass over here, this iterable. Second step, it calls the next function repeatedly in each iteration. Alright, to keep getting the next item from the iterator. So it gets 1, then it calls next, then it gets 2, then it calls next, and it gets 3, and then 4, and then 5, and so on. And then finally, the third step is the termination step, is when after we do the final next, where we get this error, as you can see, the stop iteration error or exception. Finally, this tells the for loop function or the for loop that, okay, we have reached the end of our definite iteration or the end of our definite for loop, and this is where we must terminate our loop and then continue with the rest of the code. Alright, so this is how a for loop works in Python. Now it's very important to note that whatever we have discussed when it came to while loops, such as nesting of while loops and nesting of other control structures, is also applicable in the case of for loops. So if I had a for loop within another for loop, that is perfectly fine. If I had a while within a for loop, that is perfectly fine. So all of these are valid statement blocks that we can do. And again, for loop is another control structure, and so we must follow the concept of indentation when it comes to writing our statement blocks within a for loop. Okay, so now I'm going to speak about, in specific, I'm going to speak about this something called the range function. That is quite, you could say, it's used in other areas of programming, but it's widely used in Python. I mean the for loop in Python. What I mean by this is that this range function is very important for the for loop, and we will see why. Okay, so let's look at one of the examples of using the range function. So what does the range function do is, if I give range 5, let's see what it does. It gives me range 0 to 5. What this basically tells me is that this will create an iterator that contains integers from 0 to 5. So it will contain the object 0, 1, 2, 3, 4, and 5. And we can use this as an iterator. So let's look at this. I have range 5. Let's store this in x. Okay. Now let's do a type just to see what happens when we do type x. It should give me the type of range, as you can see. And this is a type of an iterator in Python. Now let's see what happens when I do for I in x print I. Okay. Let's see what happens. As you can see, it prints the number 0, 1, 2, 3, 4. An important caveat when it comes to the range function is when we say range 5, it creates an iterator from 0 to 5, but it contains the objects 0, 1, 2, 3, and 4 only. It does not contain the object 5 itself. Okay, this is something that is very important too. So once again, I use this range function to create an iterator of 5 objects from 0 to 4, 0, 1, 2, 3, and 4. I use that in my for loop, and that is what you are seeing here. Now let's use this range function in the context of something else. For example, let's see. So I had my earlier list A, right? Look at my list A here. So you can see list A contains these 1, 2, 3, 4, 5 objects. Okay. Let's see what length of A is. Length of A is 5. Okay. Let's use the range function on top of the length of this list A. And this is like, I can't show you an example right now without any context, but this form of using a for loop is widely used in Python programming. You will use it so much in data science. You will use so much in machine learning and AI. I cannot tell you. This is a very important, like, sort of for loop expression. So you have for, let's say, I in range len A. Let's see what's going on here. First I do length of A. That gives me 5. Then I do range of 5. That creates an iterator between 0 and 4, right? When you do range 5, it gives you an iterator of 0, 1, 2, 3, and 4, as we saw earlier. And this is what we're doing over here. We have created an iterator out of the length of a list. Now when I do print I, it should give me again 1, 2, 3, 4. 0, 1, 2, 3, 4, of course. So as you can see here, it will give me 0, 1, 2, 3, 4. And this is a very neat way of using the range function on top of the length of a particular collection of objects. In this case, we're using the list A. This is something that you will use a lot. So I would recommend that you get used to this form of creating a for loop as well, using the range function. Also, of course, there are you can use break and continue statements as you have in the case of while loops. It works exactly the same in the case of for loops, wherein the break statement will abruptly stop the for loop completely and we will move on to the next piece of code. Whereas the continue statement will break that particular iteration and then we will resume with the next iteration. So yeah, that was break and continue statements in for loops. Finally, I would like to show you something about how to use dictionaries as an iterator or as an iterable when it comes to for loops. So let's create our dictionary. Let's go. We have a dictionary already here. In fact, let's create this dictionary again. We'll store it in A. Okay. So I created this dictionary A. All right. So I have dictionary A. What I'm going to do is I'm going to pass it through the iter function, as you can see. And now I'm going to just, for the sake of showing you, I'll show you that it is actually an iterator of type, of a specific dict key iterator type. All right. So now let's do something on this. So as you can see in this dictionary, I have the key first that has the value 1. I have the key second that has the value 2. I have the key third that has the value 3, and then fourth for 4, fifth for 5. Now, a good question would be, when I do iteration or when I do a for loop on top of this A, well, what is it going to pick up? Is it going to pick up first? Is it going to pick up the keys like these? Or is it going to pick up the values? Or is it going to go one by one? Key and then value and then key and the subsequent value. Let's see what actually happens. So let's do for I in iter underscore A print I. Let's see what is the iterations happening upon using this. So as you can see, we're using the keys. So by default, when we do this, when we create an iterator out of a dictionary, we use only the keys as our iterator elements or at iterator values. But of course, like if you wanted to use values, all you would have to do is pass a dot values over here. And if you remember from a dictionary video, this a dot values gives us a list of, or it gives us essentially a list of the values in our dictionary. So when we pass this to the iterator, iter function, and we create an iterator out of it, let's see what happens over here. Now let's see what is iter underscore A. You can actually see it's now the dict value iterator at a particular memory location. So it's not the dict key as we saw earlier, it's a dict value iterator. So now that we have this dictionary value iterator, now let's print what are our iterator elements. And as you can see, now we are printing values and not the keys. So this is this is basically two different ways of iterating through a dictionary, one through keys and one through values. In this video, we will be doing a small exercise on if statements. Now in the previous video, you might have already seen some of the basic concepts surrounding if statements. However, in this video, just to drive home the point or the purpose of an if statement, we will be doing a small exercise. So let's first revise some of the concepts of an if statement. So a basic if statement can be something like this. We have a small condition where we're checking if a variable x is greater than 5 or not. And if it is greater than x, we print a statement over here. So if this condition is met, we print this statement. Else, we move to this statement block. Now our variable x has the value 5. Now since x is not greater than 5, what this will do is it will check this statement, and since this will be false, we skip this statement block and move on to this statement. So as you can see here. Similarly, we can do something where we are checking multiple statements. We use the elif statement in such a case. So now in this block, we are checking in one of the conditions we're checking is if x is equal to 5 or if x is greater than 5. And then finally, if both of these conditions are not met, we say else and we print whatever, or we do whatever is in this particular statement block, which is a simple print statement. So as you can see, x is indeed is equal to 5. So this is the block that will get executed, as you can see here. Now another example are nested if statements. So nested if else statements are if else statements within if else statements. So let's look at an example. As you can see here, we have a string stored in a variable called orange quality, and the string is fresh. Now we have an integer, or a float in this case, 4.0, stored in orange price. Now our first statement is checking whether orange quality, the variable orange quality, is it equal to the string fresh. Now within that, if this statement or if this condition is met, we do another check where we're checking what is the price. Is it lesser than 5? If it is, we do this block, else we execute this block. Finally, if our initial statement or initial condition is not met, we move on to this else block. Now when I execute this, what should happen is I will enter this block because this is true, and finally I will enter this block because this condition is also true. So I should have this printed. I will buy 5 dozens, as you can see here. Now let's move on to our main exercise for this video. So this was all just a revision. Now we're going to use some or all of these concepts in a sample project or a sample exercise for your further practice. So in this exercise, what we're going to do is we're going to request the user to enter a number between 1 and 20. And our code is going to check whether this number entered is an even number or an odd number. So as you can see, there are 2 sets of checks that we're going to do in this code. The first check is going to be whether the number that is entered is between 1 and 20 or not. And if it is not, we have to say it's an invalid number. But if it is entered between 1 and 20, we have to move on to the further checks, which is whether it is an even or an odd number. So let's see how we do that. So in this piece of code, what we start with is a print statement saying, please enter a number between 1 and 20. And then we add an input command. This input command will open a box where we can enter whatever number that we want to enter. Now we use this int keyword to make sure that whatever we have entered into the input box is stored as a int data type in the enter num variable. Once we do that, our first if statement is going to check whether the entered number is greater than or equal to 1 or lesser than equal to 20. And lesser than equal to 20. So both of these conditions have to be met. If this condition is true, then we have a valid input and this statement is printed that we have entered a valid number. And then we move on to the rest of the statement block within this if statement, which is another set of if and else if statements. If our number is not between 1 and 20, we move to this block and this block prints that we have entered an invalid number. Now, once we have, say, entered a valid number, we move on to this block, this if else statement block. Now what this block is checking is whether the entered number is an even number or not. Now as we know, an even number is divisible by 2 and leaves the remainder 0 when divided by 2. So this is what this check is doing. If this check is true, that means our number is even and we get printed that our number is even. The other check or the other if statement is checking whether it's an odd number. And that means when we divide by 2, we should get the remainder 1, as you can see here. And we get printed, your number is odd. So let's execute this and see what happens when we enter a number. Now it's asking me to enter a number. Let's say I enter 17. Now that I have entered 17, as you can see, it's a valid number that I have entered. And the code is telling me that my number is indeed odd. Let's look at some other, what if I entered something else here? Let's say if I enter 16 now, since it's an even number. As you can see, 16 is also a valid number as it's between 1 and 20 and my number is even. And the code checks for that. Let's see what happens when I enter an invalid number. Let's say 25. Now when I enter 25, as you can see, it says I have entered an invalid number. And in this case, what has happened is this condition itself is not met and I have moved on to this statement block. So to give you a breakdown as to how our code has executed this, let me show you an example for the number, say 9. When I enter 9, the first check that happens, of course, is this check, whether it's a valid number or not. And since it is between 1 and 20, we move on to this block. And in this block is checking whether our number is divisible by 2 or not. And since it is not, it will leave a remainder 1. And we execute this block, which says our number is odd, as you can see here. In this video, we are going to learn about the topic called file handling. Now, file handling is basically needed because So most of the times when we're handling large and different types of data in Python, or in general, we cannot store everything into a variable, and we will have to use files. Now there are two types of files that we are going to deal with. They are binary and text files. So binary files are some of the files that most of the files that we commonly encounter, like document files, image files, video files, etc. Now all binary files are encoded in a particular format and they cannot be read by a normal text editor. And we would be needing certain specific softwares for specific files. Text files, on the other hand, do not have any specific encoding and they can be opened in the normal text editor itself. And they are like XML, CSS, HTML files, and so on. Now, there are four main operations that we can do in Python on files. They are open, read, write, and close. There are certain other operations as well, though, like rename, delete. So some of the most basic operation that we can do is obviously creating and opening a file. And the syntax is, as you can see here, where we use the open command and we give a file name and we give a mode and we store that in a particular variable. Now a mode is basically telling Python how to handle this opening. So we can have a read-only mode, which is done by this letter R, a write-only mode, which is done by letter W, and there are a bunch of other modes, such as read or write mode, which is done by R+. And we are going to see them as we encounter them. Now, it's important to note that what I just mentioned is for text files. If we are going to do, for binary files, we're going to do this file handling, then we would be using the letter B in front of whatever we were using in the case of text files. So if we were doing a read-only mode for opening a binary file, we would be using RB. And if we were doing read and write mode, read or write only mode, for a binary file, we would be using RB+. So basically just adding the B in the case of binary files. Let's look at a basic example. When we want to open a particular file, we are going to open, like in this example, I'm going to open some file called filehandling.txt in a read and write mode, read or write mode, and I'm going to store it in FO. So this is as simple as it gets. Similarly, if I wanted to do it for a binary file, since I'm using a binary file, I will use the letter B as well in the mode. And that's how you do it here. Now let's look at different ways in which we can read from a file. And there are three commands that we can use. We can use the read command followed by an optional number of characters. We can use the read line command followed by an optional number of characters, and the read lines command. So this optional number of characters is denoted by n over here, and basically it's telling us how many characters we want to print. So let's look at a simple example of where I'm going to print something called, so I'm going to take this and I'm going to do a print on top of this. So I've opened it and I've stored it in my file, and then I'm going to do a method or a function called read, and I'm going to say, like in this example, just read the whole thing. So as you can see, my file that I have opened has all of these lines. This is like the whole file basically. But now what if I wanted to open only the first 5 characters of this file, which is basically this? Well, in that case, let's open this once again. Now let's do the same read command, except we will give the character number, which is 5. As you can see, it's only printed 5. Now let's do a print read command and try to read the whole thing again. And you will notice something very interesting. Now when I do the read command, you can see it's kind of picked up from where we left off from our previous command. And that is the nature of how Python handles files. So if I wanted to again take the cursor back in such an example, I will have to open this again. And then I use this read command once again to get back to where I started from, as you can see here. Now another command that we can use is the read line command. So let's once again open. Next time if I do it, it should say big data, as you can see here. Okay. So this is the read line command. Now within the read line command also we can enter characters, and that will tell us basically that we want these number of characters from the next line. So if I want the first 6 characters of the next line, I will say 6, I will enter 6 here, and it will give me the first 6 characters of this particular line, which is the next line that is to come, as you can see here. Now another way in which we can print whatever is there in our file line by line is by using a for loop. So again, I'm going to open this file, I'm going to store it here. Now I'm going to use a for loop saying that, well, for line in my file, and what this does is basically at each iteration, it's going to take each line and store it in this variable that we enter over here, which is called line itself. And we're going to print that. At the end of the loop, what we'll have is all of the lines have been printed one by one. And another thing that we can do right now is, say we want to read a particular line. Say I wanted to read the 5th line of my file. I can use this technique where I just say, okay, I'm going to store 5 in this variable called line number, and I have this another variable called current line, which I'm going to initialize with 1, and what I'm going to do is I'm going to add a condition saying that only if current line, when it's equal to line number, am I going to print the line, and then I'm going to break out of this whole thing. And at the end of each loop, I'm going to say current line is going to be incremented by 1 until basically these two variables are equal. So when I do this, I get my result, which is machine learning, which is the fifth line of whatever file I had. Now we're going to move on to the topic of image file handling. So we saw how we handled and we saw certain operations around text files. And text files are obviously something that we're going to use a lot. But we are also going to be using files such as images a lot. And let's look at certain examples and certain use cases around image file handling. So my first step is going to be importing a bunch of modules and packages. Now the details of these modules and these packages are not important as of right now because they will be covered in a future video. But just keep a note of some of these packages such as let's say NumPy and the image package. So once I've done this, let's move on to my example. So what I'm going to do is I'm going to store certain file locations in two variables. So it's basically two strings. I've attached the this prefix R to say that this is a read-only sort of a prefix. So the next topic that we're going to be handling is image file handling. Now we have already seen many examples pertaining to text files. So text files are obviously something that we're going to be using a lot. But image file handling is something very important as well. And we're going to see certain operations that we can do around image file handling. So starting off, I'm going to import a bunch of packages and modules. What these packages exactly are and what these modules exactly are right now not that important to you right now, but it's something that will be covered in a future or in future videos. It's important to just keep note of what these are, such as NumPy and image. So once I've done that, what I'm going to store is I'm going to store two particular file locations in two variables, location 1 and location 2, and I've prefixed them with R just to say that these are raw strings. So once I've done that, I'm going to use the image from the image package. I'm going to say open, and I'm going to say open from this particular location and this particular location, and I'm going to store these images in IM1 and IM2 over here, very similar to a normal text file opening. Now once we've done this, we can access certain properties of this image using, say, format, which tells us the format of the file. It identifies the source of an image. And if the image is not read from a file, it is set to none. We can also see the size of the file using the size attribute, and we can see the mode, which basically defines the number and names of the bands in the image and also contains the pixel type and depth. Certain common modes are like L for luminescence, RGB for true color images, and CMYK for pre-press images. So let's look at them. So when I access this, you can see my first file is of JPEG of this size and an RGB format image. And my second image is another JPEG, slightly bigger image, and again RGB. Now we can also, of course, display these images, and to do that, we can use the PLT. Again, PLT is supposed to stand for matplotlib.pyplot. It's a particular package that, again, you don't need to know the details of right now, but this is how we would do this. So I'm going to use a bunch of commands and methods such as figure and subplot and then IMShow. So once I have done this, as you can see, both of my images, with this being IM1, this being IM2, have been produced on the screen, as you can see. I can also use display, this display function followed by the name of the file, and this will simply display my image, as you can see here. Now I can obviously save a particular image using the save function, which is as simple as just doing this. So I'm going to save the image as im_save.jpg over here. Now, if I wanted to crop an image, I can do that as well. So I stored the dimensions that I want cropped in the form of a tuple, as you can see here. And I'm going to pass that tuple to the crop function. And I'm going to apply that on top of im1. And I'm going to store that to region. Once I've done that, as you can see. So basically what I've done is I've cropped this image based on whatever I've passed here, and I've stored it into region. And now if I wanted to see what was actually in that crop, I can just do the IAmShow function, and I'm going to pass the particular cropped image, which is denoted by region, as you can see here. And you can see my cropped image is basically a left portion of this whole image has been cropped out, and I have produced it over here. Now I can also use the copy function. It's a simple basically copy. You use the copy function and it copies an image onto another variable that you have assigned. And when I use the IAmShow function, I'm going to show you the copied image, which is basically the same. Now we can do the transpose operation as well. So let's see let's see what we have done here. So in this transpose operation, so in this basically I've done a bunch of operations such as rotating by 90 degrees, rotating by 180, rotating by 270. And finally, once I've done with all of these multiple operations, I'm going to show you the final output, which is basically a certain transposed image like this, which is basically the result of whatever I have done before this. So this is it for this video on file handling. I have shown you two slightly more comprehensive examples on text files and even certain examples on image files. However, we can use file handling in different libraries pertaining to file handling for audio files and even for like stuff like PDF files. And this is just only the beginning, and I'm sure you will encounter a lot of different use cases, different examples as you continue learning Python programming. This video is going to be the first of a part of a series on object-oriented programming. So to start off with, let's try to understand and get an introduction into what is object-oriented programming. Well, as the name suggests, object-oriented programming is all about creating objects. An object is a group of interrelated variables and functions. Variables can be referred to as the properties of the object, whereas the functions can be referred to as the behavior of an object. So if we were to treat, say, for example, a car as an object, its properties would be its color, its model, its price, and its brand. Whereas its behavior, or functions for that matter, would be like accelerating, gear change, braking. Similarly, if I gave you an example of a dog as an object, we could consider the properties of the dog as its weight, or its name, its breed, its color, whereas its functions could be, say, barking, playing, eating, walking, etc. Objects provide a better and a clear structure for a program. Now let's move on to what is a class and an instance. Now a class is like a blueprint or a template of certain functions and entities, whereas an instance is a particular realization of a class. Classes are used to create user-defined data structures and define certain functions called methods within the class, whereas instances are realizations of these classes. And when we are speaking of classes and instances, classes don't contain any real data. They are just merely templates. Instances, on the other hand, contain real data. To think of an example of the difference between a class and an instance, think of a class like a empty form or a questionnaire. Now, an empty form or a questionnaire does not have any information, but it does have a template to it. It tells you to fill in certain information, and based on who is filling in the information, that information or the data on a particular form will be different. So an instance is like a filled out form with its own unique set of information. That is one way of treating or understanding what is a class and an instance. Now for our first example on classes, I will be taking you through a class where I've defined based on the circle object. So this class is going to define basically information about your general circle, such as its radius and its area. So let's go through it. Now obviously, to define a class, we need a keyword. Well, in the case of classes, we use the class keyword, followed by a name for that class. So in this case, my name is circle. Now, after the colon, every information that is part of the class has to be obviously indented, as is typical for Python. Now you can see over here a bunch of def keywords, followed by something that you might not be familiar with, and I will try to get you through this. So if you see here, you have a def keyword followed by init, and this init is prefixed by a double underscore and it's suffixed by a double underscore. And you can see the same thing for str and repr. Well, this double underscore is called a dunder, and any method, these are of course methods. This is a method, this is a method, this is a method, this is a method. Now any method that is prefixed and suffixed by double underscores are called dunder methods. These dunder methods are or can be thought of like predefined or built-in methods for any class that you define. So these, we have like 3 dunder methods over here, and we have 1 user-defined method that we will get to. So this first method that you see here is the init method, or the initialization method. And this is invoked or called whenever we create an instance of this class circle. And what we do here is basically we pass, when we create this instance circle, what happens is that we get an option to pass a value for what is this keyword or variable radius. So if I pass, so you will see me later on creating an instance where I will be passing a value, and that value is basically stored as the radius. And by default, the radius that will be passed whenever we create an instance for this class is 1. The str method is basically used to return a descriptive string for the instance of class. REPR is not something that you have to bother with right now. And now get area is something that you should follow, because if you see here, I have not used any double underscores. So this is a user-defined method. User-defined methods are some methods that we define, and these are like tasks that we define on our own. So in my user-defined method called getArea, I will be returning the area of this circle based on the radius that I pass to it. Now, if you notice here, before in every method, I have this self keyword before any other attribute. So like this has self, even the getArea has self. Now what this means, self is like an optional keyword that is used to improve readability of a program, first of all. And it's also the function of the self keyword is basically telling Python that, any of the methods that we are invoking in this class or the instance of this class has to refer to attributes and variables within that instance of that class. So if I'm going to use getArea function, I'm going to get values and attribute values and variable values based on only the current instance of that particular class. Self is obviously optional. We don't really need it, but basically the first attribute of any method is basically the instance that the method is invoked upon. So if I say self, I'm telling this particular function that, okay, all the value that you're going to get for performing whatever task you want is going to be found in that particular instance where you have been invoked itself. Now, don't worry if all this is very confusing. This might be in the beginning, but just try to understand that this is something that we do for good practice, and you will understand when to use self or when not to use self as you learn about object-oriented programming. So if you see here, my getArea function is supposed to return the value radius times radius. Self.radius is basically telling whatever value I've passed for radius for that particular instance. You can read this as radius times pi as well. So obviously this is pi r squared, which is the area of a particular circle. Now let me show you an example where I'm going to perform some of these functions. So if you see this first line, I have created an instance of the class circle where I've passed 2.1 for the radius of the circle. So now the value of the variable radius in this particular instance is going to be stored as 2.1, and this particular instance is going to be stored in the variable c1. Now the print c1 function invokes the str self-defined or predefined function. Now if you remember, it's basically used to return a particular string that describes like what the class will do, and this is something that we define on our own. In our example, str will return the string saying this is a circle with radius of, and then it will return the radius that we passed. So in this case, it should say this is the circle of radius 2.1, as you can see over here. So if I execute this, you can notice this line. This is a circle with radius 2.1, and this is invoked by the print function. The print basically invokes the dunder str function, which does all of this. Now in the next line, we say print c1.getArea. So this is going to print the value of what gets returned when we invoke the method getArea for this particular instance c1. So obviously in this particular instance, our radius is 2.1. So the getArea function should do pi times 2.1 square. And the value is, as you can see here, is some 13.85. So that is the area that we got. Now if we want to print a particular radius, we just say print c1.radius. So this will print the value of what is stored in radius for the particular instance c1. Now you might notice me using a dot whenever it comes to defining a certain function or a keyword. Well, anytime that we want to invoke or use a method of a particular class, we have to use the dot keyword. So we use the instance name c1 dot followed by whatever method that we want to use. So if we want to use the getArea function, we say c1 dot getArea. If we want to find out what is there in the radius radius variable of a particular instance, we say c1 dot radius. Now before we